So the observation in organic solvent, if chlorine is there, it's a colorless, bromine is there, yellow, and iodine is there, purple. Now oxidation reactions of metal and metal ion by halogen, like example, if chlorine is added to iron, it forms iron 3 chloride. So when we compare, chlorine is 0 oxidation number, iron is 0, but here in iron 3 chloride, one chlorine is -1, each chlorine is -1, 3 will be -3, so iron will be +3. So chlorine 0 become -1, so that is reduction, and iron 0 change to +3, so that is oxidation. Same way, if bromine is reacting with sodium, so it will form sodium bromide. So bromine oxidation number 0, sodium oxidation number 0. But in sodium bromide, it is +1, bromine -1. So 0 change to -1, that is reduction, and 0 change to +1, that is oxidation. Now when we check the reaction here, if chlorine is reacting with iron 2 ion, so what we observe the change, because here chlorine is 0, chloride ion is -1, so 0 change to -1, that is reduction, and iron 2 change to iron 3, so that is oxidation. Same thing when iodine is reacting with iron 3 ion, the iron 3 ion change to iron 2 ion, so this is reduction, and for iodide ion it is oxidation. So both chlorine and bromine can oxidize iron 2 to iron 3, and iodine is not a strong oxidizing agent. So what is the reason? When you check, because oxidizing agent by itself it is reduced, and reduction is a gain of electron. So when we check this reaction, the difference in the reactivity is because of their size. You have chlorine, then bromine, and then iodine. First, there is sharing of electron between the two chlorine, sharing of electron between bromine, and there is a sharing of electron between the iodine atoms in an iodine molecule. Now, what happened when it is reacting with iron 2 ion, Fe plus 2? When this Fe plus 2 is changing into Fe plus 3, so means there is a loss of electron. So what happened to the electron which is lost by iron 2 to change into iron 3? That electron is gained by the chlorine. But because chlorine is smaller in size, so it can gain electron easily. But when you compare, same thing when iron 2 changes to iron 3, it's a loss of electron, and that electron which is lost by iron 2 is gained by bromine. But compared to chlorine, the rate at which the reaction will occur will be slower. But for iodine, which is larger in size, does not have a tendency to take this electron easily. So as it does not have this tendency to take electron easily, so iron 2 will not react with iodine molecule. And because it is a gain of electron, we call that as a reduction, or the substance which help in oxidation reduction happen, or they are known as oxidizing agent, because they're helping iron 2 to convert into iron 3, which is an oxidation. So when we compare the oxidation power, so fluorine is a good oxidizing agent, then chlorine is better oxidizing agent than bromine, and bromine is good oxidizing agent compared to that of iodine. Is it clear? The oxidation means oxidizing agent means reduction, and reduction means gain of electron. Then disproportionation reactions of chlorine and chlorate 1. What happens when the same element is oxidized or reduced? In short, you can say disproportion reaction. So example, if chlorine is bubbled through water, it will form HClO and it will form HCl. So what is the oxidation number of chlorine in HClO? One oxygen is -2, hydrogen is +1, so chlorine is actually +1. And in HCl, hydrogen is +1, so chlorine is -1. So chlorine, which is an element, changes 0, changes to +1. So that is oxidation, and the same 0 changes to -1, so reduction. Same element is oxidized or reduced. So chlorine in both simultaneous reduction and oxidation changes in oxidation number from 0 to -1 and 0 to +1. And what will happen if some universal indicator is added? It will first turn red. Why it will turn red? Because HCl is acid or acidity of the both product. But it will then turn colorless because HClO is also having a tendency to bleach, or it is having a tendency to decolorize the substance. So chlorine is used in water treatment to kill bacteria, and it has been used to treat the drinking water and the water in the swimming pools as well. The benefit to health of a water treatment by chlorine outweighed its toxic effect. Like, it is toxic, but because it is having more advantages as compared to that of disadvantage, that's why still a chlorination is done. Now, when they are reacting, you have to learn these reactions: reaction with cold sodium hydroxide and reaction with hot dilute sodium hydroxide. So example, we have chlorine, bromine and iodine in aqueous solutions, and will react with cold sodium hydroxide, and the color of the halogen solution will fade to colorless. So basically what happened, like example, when you add this chlorine bubble or add the solution of the chlorine to aqueous sodium hydroxide, it will form sodium chloride, sodium chlorate 1 plus H2O. Now, what is the change in oxidation number for chlorine? It's a molecule element 0. In sodium chloride, it is -1, and sodium chlorate 1, it is +1. So 0 change to -1 reduction, 0 change to +1 oxidation. And the mixture of sodium chloride and sodium chlorate 1 is used as a bleach and disinfectant or to kill bacteria. But if we have a warm sodium hydroxide, what we observe? We'll observe that the hot alkali will cause a greater change in oxidation number. As you can see, chlorine is 0, here chlorine -1, but in NaClO3, what is the oxidation number? One oxygen is -2, so 3 oxygen will be -6. Sodium is group 1 +1, so chlorine is +5. So chlorine 0 change to -1 reduction, 0 change to +5 oxidation. So greater change in oxidation number or higher oxidation state is there when it is reacting with hot dilute sodium hydroxide. Same thing happens for potassium. This iodine reacting with potassium hydroxide. When we write the oxidation number, so iodine is 0 here, potassium plus 1, iodine minus 1, KiO3, 1 oxygen is minus 2, 3 oxygen will be minus 6, potassium plus 5, so iodine should, potassium plus 1, so iodine should be plus 5. So 0 change to minus 1 reduction, 0 change to plus 5 oxidation. How we name these compounds? Like NaClO, it's sodium chlorate, and this is a Roman number which is used for showing the oxidation number of chlorine, that is 1. NaClO3, that's also sodium chlorate, but what is the difference? The oxidation number of the chlorine is plus 5, so it is sodium chlorate 5. So these reactions are important. You have to learn these equations. Then iodine and thiosulfate titration. What we will do in iodine and thiosulfate titration? In this simple titration, iodine is reacting with thiosulfate, so result in a formation of iodide. The solution will turn from yellow brown to colorless, or if we use a starch, it will turn from purple to colorless. The main purpose of this iodine thiosulfate titration is used to find the concentration of oxidizing agent. The main thing is it is used to find so how we can find the concentration of oxidizing agent. Example, you have a container which is filled with oxidizing agent and you want to find the concentration of this oxidizing agent. So what you will do, first you will take out not all of it by using a pipette or using a measuring cylinder or using burette. You take small quantity. Example, you took 25 cm cube of this oxidizing agent and add this oxidizing agent into a conical flask. So we have oxidizing agent in the conical flask. Then what we will do, we will add excess of potassium iodide, aqueous. Now what this will do, when we add an excess means like more than enough or too much potassium iodide. So when we add this potassium iodide, this oxidizing agent, the term oxidizing agent help in oxidation, by itself it is reduced. So what this oxidizing agent will do, it will convert, because in aqueous potassium iodide, iodide ion is there which is -1, so that will turn into iodine molecule when it will react with potassium is a spectator ion. So basically the first thing what will happen, iodide ion which is present in potassium iodide convert into iodine molecule. So as we use in excess or more than enough potassium iodide, so we are left with oxidizing agent is used up because we add too much. So now what we are left with, we are left with iodine molecule and the oxidizing agent is used up. So if it is high in concentration, if it is greater in concentration, it will be brown in color. If it is low in concentration, it will be yellow in color. But originally, because we had too much excess of potassium iodide, so more iodine molecule, so initially the solution is brown in color. Then what we will do, we will fill the burette with thiosulfate. It can be sodium thiosulfate, So up to the mark, the zero level, we fill this with a thiosulfate. Now what we will do, we will add this thiosulfate because the reaction between iodine and thiosulfate, as you can see, this is a thiosulfate ion H2O3. So when we add thiosulfate to iodine, a solution contain an iodine molecule convert into iodide ion. So as the amount of iodine molecule in the solution decreases, we are adding a thiosulfate, which is H2O3, and reacting with iodine molecule form iodide ion and S4O6. So when iodine molecules are reacting with thiosulfate, they are converting it to iodide ion. So means the amount of iodine is decreasing. So the solution will turn yellow or pale or light in color. So when the solution will turn light in color, that moment we will add a starch as indicator. So we will add a starch as an indicator. So when we add a starch as an indicator, in the presence of the iodine, the starch will give a blue-black color. So it will be a dark color. So solution will turn darker at the moment we add starch. So first initially we did not add the starch because if you add starch from the beginning, this will affect the result because iodine mixed with a starch and you need a greater quantity of thiosulfate to remove iodine from the starch. So when small quantity of iodine is left in the solution, that time you will add starch. And how you will identify that small quantity of iodine is left in the solution, as the solution will turn lighter or paler. And then what you will do, now you will continue adding this thiosulfate until all of the iodine used up. So when all of the iodine used up, the blue black color of a starch which was there due to the presence of iodine, it will turn into colorless. So the blue black will turn into colorless. And that is the point you can identify that how much thiosulfate is needed. So you know the concentration of thiosulfate, we know the volume of thiosulfate, so we can find the moles of thiosulfate. Because concentration is known for thiosulfate, we fill the burette with a known concentration of thiosulfate, and volume we will read from the burette. So concentration into volume will find how many moles of thiosulfate are there. Now after getting a moles of thiosulfate, you will get moles of iodine, and from moles of iodine you will get moles of oxidizing agent, and moles of oxidizing agent divided by the volume of oxidizing agent. So you can find the concentration of oxidizing agent. Is it clear, this procedure, the titration, iodine and thiosulfate titration? So if I write in steps, these are the steps for iodine thiosulfate titration. First, what we will do, we will take a fixed volume of oxidizing agent. That is one thing. Then we will and transfer to a conical flask. Then what we will do, we will add excess of potassium iodide, aqueous potassium iodide. The solution will turn brown due to iodine molecules. Then we will fill the burette with sodium thiosulfate. Then add thiosulfate from burette until color of the solution turn paler or lighter. Then when it turned paler or lighter or yellow, what we will do, that moment we will add starch as an indicator, which will make the solution blue black. And we will add thiosulfate until the color disappear. Then what we will do, record the volume. So we'll record the volume of thiosulfate and use concentration to find moles of thiosulfate. Then use ratio to find moles of iodine and oxidizing agent. Then use volume and moles to find concentration of oxidizing agent. Is it clear, this procedure steps for iodine and thiosulfate titration? Any doubt or a question in this? Is there any question or a doubt? Then reactions of halide with concentrated sulfuric acid, and these reactions of halide can also be used to identify the reduction power of these halide ions. So reduction power by themselves, they are oxidized. Oxidation is a loss of electron. So when we compare the reduction power, it is opposite. Oxidation power of fluorine is more than chlorine. Chlorine is more than bromine. Bromine. But when we compare their ions, iodide ion is good reducing agent compared to, because it's a iodide ion is larger in size, so it can lose electron easily. So oxidation happen easily for iodide compared to that of bromide, and bromide can be oxidized easily compared to chloride, and chloride can oxidize easily. Oxidation of these ions means loss of electrons. So iodine can lose electron easily compared to bromine compared to iodine, because bromine compared to chlorine, because of the size. So when we are comparing their strength, so we can react them with sulfuric acid. So if it is a good reducing agent, it will reduce the sulfur to lower oxidation states. And what are the states of sulfur in different compounds? As you can see, like if I say, if it is sulfate ion, each oxygen is minus, one oxygen is minus 2, so each oxygen will be one oxygen is minus 2, four oxygen will be minus 8, so this will be plus 6. So sulfur in sulfate ion it is plus 6, but it can also be sulfite ion. So this is minus 6, so in sulfur will be plus 4. It can be sulfur dioxide. In sulfur dioxide, one oxygen is minus 2, so two oxygen will be minus 4, so sulfur will also be plus 4. It can be sulfur in which oxidation state is 0, and it can be hydrogen sulfide in which this one will plus 2 for 2, so sulfur will be minus 2. So these are some compounds of sulfur which are having different oxidation state. So when we are reacting with chloride, bromide or iodide, the one which reduce the sulfur to a lower oxidation state, it means that is a good reducing agent, or itself it is oxidized. So as we react, like example, fluorides and chloride. We react sulfuric acid with sodium fluoride and sodium chloride. As a result, it forms sodium hydrogen sulfate and hydrogen fluoride. So sulfuric acid is not as strong enough as an oxidizing agent to oxidize the chlorine, uh, oxidize the chloride and the fluoride ion. So there is no redox reaction here, only this is an acid-base reaction. So sodium is plus 1, fluorine minus 1, each hydrogen plus 1, each oxygen minus 2, sulfur will be plus 6. So sodium plus 1, hydrogen plus 1, sulfur plus 6. So all these compounds, there is no change in oxidation number of sulfur or even for chloride. That's why we don't say that this is a redox reaction. And whenever hydrogen halides are there, what we will observe? We'll observe a steamy fumes. Because why we call this as an acid-base reaction? Because acids are proton donors, bases are proton acceptor. This is donating proton, this gain proton. That's why we call that as acid-base reaction. But if we carry out the reaction with, when we carry out the reaction with, say, sodium bromide is reacting with sulfuric acid, sodium bromide is reacting with sulfuric acid. So what happened? First, there is an acid-base reaction. It will form sodium hydrogen sulfate plus hydrogen bromide. Now this hydrogen bromide is reacting with sulfuric acid. The second reaction is a redox reaction. How the second reaction is a redox reaction? Hydrogen is plus 1, bromide ion is minus 1. For total, I will write at the bottom and individual I'll write at the top. So one oxygen is minus 2, four oxygen will be minus 8. One hydrogen is plus 1, two hydrogen will be plus 2. So sulfur should be plus 6, so that overall it will be neutral. So here in sulfuric acid, sulfur is oxidation state is plus 6. But when it forms sulfur dioxide, one oxygen is minus 2, two oxygen will be minus 4. So sulfur is plus 4. So sulfur plus 6 changes to plus 4. So sulfur is reduced here, the oxidation number of sulfur, reduce from +6 to +4. So what we can call this bromidine, which is oxidized. So bromidine is a reducing agent. And what we will observe, what are the observation? You have to memorize these observation. First, we will observe a steamy fume because of hydrogen bromide. Red fumes because of bromine. And acidic gas, sulfur dioxide, or a pungent gas you can also mention, is evolved. But if we carry out the same reaction with iodine, then there are different possibilities. What are the possibilities? The first reaction is an acid-base reaction. Sodium iodide react with sulfuric acid, form sodium hydrogen sulfate and hydrogen iodide. But the second, these reactions, these are all possibilities that this reaction can happen. This can also happen, or all of them can also occur. So hydrogen iodide react with sulfuric acid, it form iodine molecule, sulfur dioxide and water. So what we'll observe, because iodine molecule is there, so due to the presence of iodine molecule, we'll see purple fumes or a black solid. If it is solid state, black solid. If it is vapor, purple fume. Hydrogen iodide is there, so that's why misty fumes or steamy fumes, sorry. This misty fumes you can also mention. Then if hydrogen iodide, more hydrogen iodide molecule react with sulfuric acid, so it form iodine molecule and sulfur. So if it forms sulfur, what we'll observe? We'll observe a yellow solid. If it form hydrogen sulfide gas, then it's a rotten egg smell or bad egg smell is there. Like if an egg is rotten, there's a bad smell which is due to hydrogen sulfide. So with what it shows, that this reaction shows iodines are good reducing agent, because when they are reacting with sulfuric acid, they can give a different product, variety of the product, which have different oxidation state. The sulfur may have oxidation state +4, means sulfur dioxide can be there. Sulfur may have oxidation state 0, so sulfur alone is there, or it may have -2, so hydrogen sulfide is there. Is it clear? The reactions of iodine with sulfuric acid. Any doubt in this? So you have to learn this pattern and the reactions. But it is not necessary that you memorize the equation. You don't have to bother about memorizing the equation, because already we discussed balancing a redox equation. So if I say I want to produce with sulfuric acid reacting with hydrogen iodide, or iodine is reacting with sulfuric acid, and I want to produce sulfur as a product. So how to balance a redox equation? If you remember, to balance oxygen, we add water. So there are 4 oxygen, so we'll add 4 water molecules. Then to balance the hydrogen, we add protons. And then we balance the charge. I wrote the equation all together, but for example, you're reacting iodine forming iodine molecule. This is one equation. And sulfuric acid is forming a product, sulfur. And you want to write a balance equation. So the first equation, there is no oxygen or hydrogen. So I have to first balance the molecule and then balance the charge. The total charge is -2 on the left hand side. So -2 on the right hand side. I will add 2 electrons. About the sulfuric acid, H2SO4. So changing into sulfur. So first we have to balance water, oxygen by adding water molecules. Then we have to balance the proton. Already 2 are there. 8, we have to add proton by to balance hydrogen. 8 on the right hand side, 2 are there, so we'll add 6 protons. Then we have to balance the charge. How to balance the charge? overall right hand side is completely neutral, left hand side is plus 6, so we need a neutral, so we'll add 6 electrons here. But the number of the electron loss and gain should be same. So if this is having 6 electron, the other should have the same number. So if I multiply this equation by 3, so what it will turn to be, it will be 3 iodine, sorry, 6 iodine, because 2 is already there, so 6 iodine and 3 iodine molecule, and 3 multiplied by 2, 6 electron. We'll add the two equations. So what we are left with? We are left with 6 protons, 6 iodine, H2SO4 gives 3 iodine molecule plus sulfur plus 4H2O. So that is a balance equation. So if you don't like, you don't have to memorize, you can even work out the equation. Memorization just only save your time in exam, but otherwise you can use your understanding of balancing a redox equation to write the final equation. As you can see here, same equation, 6 H2SO4, 3 I2 sulfur, and 4 water molecules are there. Then if we want to test these ions, halide ions, we can add silver nitrate. It will give white precipitate with chloride, cream precipitate with bromide, and yellow precipitate with iodide. And if we leave them in or exposed to the light, so the solution will turn darker. Why? Because of formation of silver atoms. So this is a test for halide ion. Then you can also use the confirmation test, that if you add aqueous ammonia, dilute and concentrated have different effect. If you have sodium silver chloride is formed, it will dissolve in dilute ammonia, as well as you don't have to memorize this complex equation. But if you have silver bromide, it will only dissolve in concentrated. And if you have silver iodide, it does not dissolve in dilute or concentrated. So silver chloride is soluble in both dilute and concentrated ammonia. Silver bromide is only soluble in concentrated ammonia, and silver iodide is insoluble. So this is also a test for confirmation. So producing a hydrogen halide, so hydrogen halides are made by reaction of solid sodium halide with phosphoric acid. And observation will be misty fumes. And phosphoric acid is not an oxidizing agent, so it does not oxidize hydrogen bromide and hydrogen iodide. Phosphoric acid is more suitable for producing hydrogen halide than the concentrated sulfuric acid, because concentrated sulfuric acid can react with hydrogen halides as well. So the solubility, because they can form hydrogen bond, so these compounds are water soluble. And if we want to test if hydrogen halide react with ammonia, or bromide react with ammonia, or iodide react with ammonia, it will form a dense white smoke. So this was group 2 and group 7. We completed this topic as well. Any question related to this part? Any doubt or a question?